Chapter 3, manipulating and solving equations. So in this chapter mostly we try to manipulate, we try to move equations from LHS to RHS, RHS to LHS to get the thing what they asked for. So that's what we do mostly, we just manipulate and solve them. Coming to the next topic, um, here the first thing is combining like terms. Like terms, you already know about like terms, like something like 2a plus a, 2b plus b. These are like terms, like 2a are like terms. You can't add up 2a comma 2a and b, you can't add them up. These are not like terms, you can add only like terms like 2a like that. So uh, already know about this combining things. Let's directly attack question 1. So here you can see what we are doing in this. First we multiply this. Finally what do we need to find? We need to find the value of a. To find the value of a, first let's solve this part. When you multiply 2 with a, you get 2a, 2b, 4c, 6d and 2, and RHS is same. So now after getting things on the LHS and RHS is as it is, we just multiplied this 2 with the complete parenthesis, and then we just crossed out here 2b, 2b, 4c, 4c, 6d, 6d. The like terms on the LHS and the like terms on the, I mean the same terms on the LHS and RHS gets cancelled out. Even if you just transpose to LHS, they get subtracted from them, because this positive 60 becomes negative 60. By doing this way you end up with a value as 2. That's it. It's a easy topic, combining like terms. Now square equations correctly. So here you have an equation, you have to solve this by squaring up. How do we know that we have to square up? Because the equation is given in root. If something is in root, how can we end up? We actually try not to be with a root any equation. And also, how do we know? We have to remove the root. You see the options, none of the options are with root. So how can we remove root? By squaring on both sides. This is one way. So the thing is squaring equations correctly. Whenever you square up, you're not only squaring up on the LHS, you are going to square up both sides, then only it's balanced. So you square up on both sides. So that's what it is. You can't square individually. Now, so how do we do this? Just square up. What do you get when you square? You get crossed out with this root square and root of, and then when you square here you get a minus b whole square. So what do you get? AB equals to a square plus b square minus 2ab, because this is a minus b whole square. Now AB equals to this AB. I mean, you see the options. If we can make up this as 3ab, because we have all options with a square minus b square plus b square. So on doing that, this 2b, negative 2b transposed to LHS, we get positive 3ab. That equals to a square plus b square. So which is option D. This is how you remember one thing. Whenever you square on both sides, you have to do both sides. You can't do individually for only one term. And when you need to do this squaring on both sides, mostly when you have the root in the question. So here you have a question and you have to get one of the options here, and the main question is you have to express x in terms of y and z. You want only x, you want only x, you don't want y, and you don't want 3, you don't want y, you don't want this root. So how can you do that? Like you just try to eliminate root, try to eliminate 3, try to eliminate y, you will get the x value. That's what they're asking us to find. Get the value of x in terms of x and in terms of y and z. So you just directly not to do squaring on both sides, because it's going to be a bit complex, because 3 terms are there here, like individually root x, root 3 and y, 3 terms, right? It's going to be like a plus b plus c whole square. It's going to be complex. So what you do is instead try to send this y to other side. It's going to be negative y when you do that, and then you end up with root x plus 3 on the LHS. So now it is easy to calculate. Why? When you square up also, this root will be gone in one moment. But If you do it this way, it's going to be time consuming. I'm not saying it's incorrect, but it's time consuming not to go in that way. And when you square up this, just apply the a minus b whole square formula and you get the final result. Is that okay? Yeah, thank you, Mr. Saidu Rahman. So here square root equations correctly. So when do you use square root on both sides? Whenever you have x square term in the question, you will square root on both sides. So this is the main thing when we do. And whenever you do square root on both sides, like let's say x square equals to 25, you want only x, you don't want x square. What do? How can we eliminate that square? We just apply root on both sides, square root on both sides. And whenever you do square root on both sides, remember this is the main point, square root on both sides. Whenever you do square root on both sides, what happens? X square that equals to 25 and then square root plus or minus square root. So here you have to keep plus or minus whenever you do that. Whenever you apply square root on both sides, plus or minus comes into the picture. To know why about this concept, it's a time consuming concept. If you want to know about this, why it is plus or minus coming into the picture, I already made a video on this. Go and watch. It's in the algebra playlist, third chapter, say manipulating and solving equations. There you just go and somewhere in the middle, exactly at this point, you can find why we are doing this plus or minus. As of now, I'm just going with this. Whenever you do square root on both sides, you get a plus or minus here. And don't think that whenever it is because plus 5 whole square will give you 25 and minus 5 whole square will give you 25. No, this is not a reason for that. That's why I said it time consuming. Go back and watch the thing what I did previously. Definitely this is not a reason for that. I did a video, watch that. You understand why this plus or minus comes into the picture, especially when we do square root on both sides. Now people think that like root positive 5 whole square and root negative 5 whole square will give you the same result. No, like positive 5, root positive 5 will be 25, root negative 5 will be positive 25 only. But this is not the reason. This is not the reason. No. So go back and watch there. As of now, I'm moving with this info itself. Not now, just once class is done. Now, root x square equal to plus or minus root 25. So we end up with what? X equals to plus or minus 5. So this is what we end up with. And when do you need to use square root on both sides? When you have square on the question and we want to eliminate that square, we use root on both sides. It to balance, we have to do it on both sides. We can't do it for individual term. And remember not to forget this plus or minus comes into the picture whenever you do square root on both sides. And you see here, root of any value, root 9, root 25, root of any value is positive. Root of any value can't be negative. But root of 9 value can't be plus or minus 3. No. Root 25 value can't be negative plus or minus 5. No. Root of some value can't be negative. That's it. And root 9 I already mentioned here is only 3. Root values all are positive values only. Root value can't be negative. And one more thing here, x square equals to 9, then it has two values. I can tell you two values. It is a x square it has 2 on power, which means it has two solutions. Like it's a quadratic equation. So it has two solutions definitely. So here x equal to plus or minus 3. Whenever it is x square equals to 9, then x value is going, I think you can't see me behind this one. Okay, I think it is fine now. X equals to plus or minus 3. No, x equals to plus or minus 3. Yeah. Whenever it is only x square term is there, then this is going to work. Whenever it is only root of 9, root of 25, it's only positive value. It can't be negative value. Remember that. And let's go for the question. Example 4. If x plus 3 whole square equals to 121, what is the sum of the two possible values of x? So here, sum of the two possible values of x. What does that mean? If you solve this question, you are going to get two possible values, and indirectly mentioned you are going to get two possible values of x. And what is the sum of that? How do you solve this? You have to get the values of x, two values of x, and then you have to sum up. But how do you get that? Here the thing is in square. To remove that square, why do we need to remove square? Because we need x. We don't want square thingy. We don't want this 3 also with x, because we want only x value. So how to remove this square? Root on both sides. Whenever you apply root, you see here plus or minus, and root will come into the picture. It's not inside. Plus or minus is not coming from the inside thing. And root of x plus 3 whole square, that equals to plus or minus root 121. Now the square and root of, we get x plus 3 plus or minus 11. Root 21, root 121 is 11, root 11 square, which is 121. So that's why we went this way. And x equals to, forward this 3 to other side, it's going to be negative 3 plus or minus 11. So just do the thing. You are going to get x values. You will get negative 3, positive 11 will result in positive 8, 1x value. X equals to negative 3 plus 11, and x equals to negative 3, negative 11. So you end up with x equals to positive 8, and you end up with x equals to negative 14. And they asked the sum of this. Sum them up, 8 and 14. If you sum them up, 8 minus 14, that is negative 6. That's what our answer is. Is it clear? If it is clear, just type clear. Yeah, thank you. Moving for the next one. So now cross multiply when fractions are set equal to each other. So it's a basic concept. You have two fractions equal to each other, then what we do, obviously we cross multiply. That's it. Here you have an example, 4 by 5 x equals to 10 by 3. What is the value of x? So how can we get the value of x? To get the value of x, try to remove all the things with x. What all with x? Try to remove. How do you remove? Just multiply 5 by 4 on both sides. Multiply 5 by 4 on both sides, so that you can get rid of this 5 by 4. 4, 4, 5, 5 out. You get the value of x. Or else what you can do, just transpose the fraction to RHS. Transpose this fraction to RHS. That's going to be 5 by 4. That's way also you can do it. Hope you can do this just by cross multiplying. So when you do that, what do you get? That is one way. Just the thing whatever I said now, two things, that is one way. And now you can cross multiply also, 3 with this and 5 with this. What do you get? 12x and 50. That is also another way. So x equals to 50 by 12. Just transpose this 12 to RHS. 50 by 12, which is 25 by 6. So now here example 6. The given equation relates the positive numbers a, b, c, which equation correctly expresses a in terms of b and c. So how do you solve? Here two fractions are given. It is directly you can solve this and multiply this with 0, or else what you can do, transpose this term to RHS, then you will get proper two fractions equal in between them. So you can just cross multiply them. Just this denominator with the first numerator, first denominator with the second numerator, multiply, and then you just get these terms. Just do the things whatever needed. So you get from here, I'll just try to solve. So you 2 into a, 2a, plus 2 into bc, 2bc, that equals to 5bc. So 2a, what do we need at the end? We need a in terms of bc. So 2a equals to 5bc minus 2bc. I just transpose this. So now 2a equals to 3bc. A equals to 3bc by 2. That's what we need to find. We need to find value of A in terms of BC. Now let's go for the next one. Factor to isolate variables that are common to multiple terms. Some equations have variables that are tougher to isolate. For a lot of these questions, you will have to do some shifting around to factor out the variables you want. Nothing else. Just here you have something and you just want to find the value of A. I'm done trying to teach with the example. You want the value of A. How do you get the value of A? Like, you don't want things with A. You just want A. What do? You just try to isolate. You try to remove this complete denominator part. If you send it to other side, you will get the value of A. Just removing the denominator, you get the value of A. That's what we are going to do. Nothing else. So now just multiply this denominator with this and we are going to get 3 into AB, 3AB plus C, B into C, BC. And remember one thing, till now we did this, but at the same time you have in the denominator you have A term. Whenever you have two A's in the numerator and denominator, or they are in product, or the same A terms in the LHS and RHS, and they are asking us to find the A value, if 2 or 3 terms are there on the LHS and RHS, make these all like terms put together and then take out the A common out of it and then shift this and the part which is with A now. So that's what we are doing. We have two terms here, A. We need to find the value of A. I just thought only A is there and I just went ahead like that. Till now we did it in the same way, but two A's are there in the question. If that is the case, just take put A terms together. That's what we are going to do. So here A is there, and after multiplying this 3AB, we are shifting to, we are transposing to RHS. When we transpose, this is what we get, A minus 3AB. So we take A common in the next step. After taking A common, we get 1 minus 3B. And now you transpose this to other side. Why? Because you need only A term. When you transpose, you get this term finally. I think it makes sense now. Just type fine if it is fine. Yeah, thank you. So now here be comfortable for solving for expression rather than one variable. So here you see in the given question here, 3x plus 9y equals to 9. What is the value of x plus 3y? So if you observe carefully, this and LHS of this and LHS, the given question is almost same, just only 3 is the difference. Like this LHS is multiplied by 3, that is the difference. So if you just divide this complete equation by 3, what do you get? If you take out the 3 common in the LHS, you get 3 into x plus 3y. That is same as this. So divided by 3, this 3 out, and here 9 divided by 3, we end up with 3 as the result. Let me do it. 3x plus 9y equals to 9 given. They are asking us to find the value of x plus 3y. So if you watch carefully, this 3 is the common thing, x plus 3y, that equals to 9. I just took 3 common out of it. Now I try to divide 3 on both sides so that I will get x plus 3. That's what I'm looking for. So this is out, 3 times 1 and 3 times 3. So x plus 3y, that equals 3. This is what we need. And in example number 10, they are asking us to find 3 minus x by 2, which is here inside this one part they're asking us to do. If you want this, what about if I eliminate this part? If I eliminate 4, the value of this will be 23. So we just have to find this. How can we do that? From the given equation, we just have to remove this 5 forward to RHS. It's going to be 23 plus 5, that's going to be 28. And then this also forwarded, it's in multiplication, it becomes division. 28, 4 if you forward, 28 divided by 4, which is 7. So the value of that is 7. Now example 11, they given x by y equals to 3, they given. They're asking us to find the value of y by 2x. So how do we get the value of y by 2x? So here if you see, here we have y by 2x, here we have x by y. How can we turn this into x by 5? Just flip it directly, it will turn into y by x, which means you have to flip this side also. It is 3, nothing is there means 1 is there, that's what you need to consider. So it's going to, when you flip it, it will be 1 by 3. That is one thing. Or else you can transpose also. If you transpose this, it will become y by x. If you transpose 3 by 1, it will become 1 by 3. You can do transpose thingy or just flip it on both sides. So what I'll do is, in the place of this 1 by 2, I'll just write this 1 by 2. Y by x, in the place of y by x, I'm going to write 1 by 3. So 1 by 2 times 1 by 3 is 1 by 6. That is the answer, 1 by 6. So moving to the next one. Watch out for extraneous solutions and missing solutions. See, what do you mean by this extraneous solutions? Which means false solutions. Extraneous solutions is nothing but false solutions. This is the main concept. Till now the basics are done. Here the main topic starts. This one and the next one is the main topic. Now what do you mean by this extraneous solution? The meaning of extraneous solution is false solution. I already mentioned. When do you get false solution? When you do multiply on both sides, you get false solution. When you do divide on both sides, you miss with a solution. Missing solution you miss with a solution. I'll tell you why this happens. Here we have let's go with an example. So here in this example, we try to find the value of x. How do we find the value of x? It's so easy. You can directly cross out this x minus 5, or you can do what? Multiply x. Generally what we do, multiply x minus 5 on both sides. Why do we do that? Because we want to get rid of this x minus 5 which is in the denominator. So if we get rid of this, we will get these two things, like x minus 5 equals to 0 and x minus 3 equals to 0. This is what we ended up with, numerator, which means x equals to 5, x equals to 3. So you got two solutions here, but two of them is not going to true. They are not true. Whenever you do multiply on both sides, whenever you do what you did here, multiply this on both sides for a fractional expression, fractional equation, you get a false solution. You got two values, x equals to 5 and x equals to 3, when you multiply x minus 5 on both sides. But how do we know that the one among them is false? Take that 5. We got 5, right? X equals to 5 we got, x equals to 3 we got. Let's take that 5 and put it back into the equation. You see, I'm just taking 5, put it back into the x minus 5 into the equation. X minus 5, 5, wherever x is there, I just kept that. And what answer I got here? 0. 5 minus 5 is 0. 0 into anything is 0. And then denominator also 0. Finally, I got 0 by 0. 0 by 0 is nothing but undefined, not possible, undefined. But what do we need to get? We need to get 0. That is the RHS. It's not satisfying. The value what we got, x equal to 5, is not satisfying. If you take this 3 and put it back into the equation 3, you will get some value which is 0 by negative 2. 0 by negative 2, which means 0. Which means this 0 is satisfying the RHS. Which means this is the only solution. Which means this is the only solution. You see, you got 0 as your RHS. So remember, when you multiply things on LHS and RHS, you end up with a false solution. But still we do this because we want answers quickly. We want to do solve the question quickly to save time. And how do we know that which is true and which is false? Just try to plug it the way how I did. I plugged 5 here, so 0 in the numerator, 0 in the denominator, so 0 by 0 undefined. If you plug 3 here, if you plug 3 in the RHS, here 3 minus 3, 0, 0 into anything is 0, 3 minus 5, which is negative 2. So what happens here is you get 0 as LHS and RHS 0, it's satisfying. That's how you make it clear that you are on a right track by plugging it, which is the right solution. And why do that happen? I just tell you one thing. Whenever you do squaring on both sides here, what do you get if you square up? If you square up, you get x equals to 16. You get, if you square up, you get 16. However, it's not going to satisfy the original. If you just do this square and root of, and negative 4 square is 16, but the same equation root x, that equals to negative 4. But if you put this x value into here, x root of 16 is not satisfying this, because root 16 is 4. Root of any value is positive, not negative. So when you put back this original value, what you got into the equation, you're not getting a positive, you're not getting a negative value, because it's in the initially it is negative 4, but we are getting positive 4. So whenever you do squaring on both sides, there is some change. What is that change? The negative sign changes to positive. Because of this, false solutions will arise. When you square up, the equations, for instance, has the effect of turning negative values into positive values. So this negative 4 turned into positive value. So we think that it is true, but it is not. That's why the false solutions arise. So how to pick the right solution? You just do multiplying on both sides, but switch them and conclude that this is the right answer. That is the main thing. Now one more topic. Here this is all about missing solution. The topic is missing solution. So how do we miss solution? Generally what we do, we have to, what is the sum of the solutions to the given equation? You need to understand that they used a word called sum, which means you are going to get two x values. Then you have to find the solution. Indirectly they said it is going to have two solutions. So two or more. Sum of the solution. How do you get the solutions? What do? You just want to get rid of this x plus 4 on both sides. In the previous case, what we did, we just multiplied x minus 5 on both sides so that you get rid of the denominator part. And now you can see here x plus 4 is same on the LHS and RHS. To get rid of that, to solve it faster, we divide x plus 4 on both sides. So when we divide x plus 4 on both sides, you get rid of this x plus 4 in the numerator, denominator, and you end up with x minus 9 that equal to 1, and you solving, you get 10. But the 10 is the only solution? No. How do we know that that is not the only solution? Let me solve x plus 4 and x minus 9 that equals to x plus 4. So now what I do is x plus 4. How to solve actually? X minus 9 minus x plus 4 that equals 0. I just transpose this to LHS. Now I'm taking this x plus 4 as common because it's the same thing in both. So x minus 9 minus 1. So if you consider this as x plus 4 one term, so I'm just putting minus 1. X minus 9 minus 1 that equals 0. So x plus 4 and x minus 10 equals 0. So what is the x value? X plus 4 equals 0 and x minus 10 equals 0. X equals to negative 4 and x equals to 10. So what are the x values we got? 1 is 10. We also got one x value as 10, but we missed with the solution. Whenever you divide, you miss with a solution. That is all the topic is about. I think you are unable to see the right side part. I'm just scrolling. I think you can able to see now. Yeah, I just solved this part. Just check it. After solving, I got x value as negative 4 and negative 10. This is the right way of solving it. But why we are not going with the right way? Because that's time consuming. We want to solve it quicker. To mentally also we can calculate. If we just divide by x plus 4, you know that this is all done. X equal to 10, you can say just mentally without doing any calculation on the paper. That's why we follow this one, to do it quickly. This is the trick. But we end up with a missing solution. How do we know that we end up with a missing solution? Here it is easy. The thing what we are assuming that it's not a solution and dividing it on both sides. We are assuming that x plus 4 is not a solution. But whatever we assume, just consider that, and x equals to x plus 4, just equate it to 0 later on once you got this x equal to 10. Once you got this x equal to 10, just consider this equal to 0, x equal to -4. This is the trick. Whatever you divided by, you are assuming that it's not going to be a solution. That's why you are missing with the solution x plus 4. So now whatever you divided, once you got the solution, you equate the value what you divided with. That will give you the missing solution back. So this is the way you can solve it faster, instead of going the original method which I wrote it on the right side. Yep. So follow this, but what do you need to do? Divide and you end up with a solution. You know that by using this method you miss with a solution, and then what you do, equate it to the right, equate it to the 0. You get x equals to -4. This way you can quicker. You can solve quicker. So you see, why do we miss with a solution? Dividing both sides by x plus 4 to find one solution, we made another more obvious solution disappear x equal to -4. Plugging x equal to -4 into the original equation yields 0 on both sides, so it's clearly a solution. So whatever we assume that it's not going to be a solution and we divide it by 0. But that is also a solution. How do we know? If you have any doubt, you can plug back into the equation. We got x value as -4. We got this x value as -4. Just put back into the equation here, x equals to -4. If you put x equal to -4 here, -4 +4 0, 0 into anything is 0, -4 +4 which is 0, RHS LHS satisfying, which means this is also a solution. So this is the fastest way. Just divide on both sides. You know that you are going to miss a solution. Just whatever you divided with equal to 0, and check back that it is a solution or not by plugging it into the equation. I don't think it's no need to check back, just to for your thing I say, for your understanding I'm telling you, but definitely what you divided with will be a solution. Done with the complete topic. I'll just end up here. Tomorrow, in the next session, we start with the exercise 1 and exercise 2. Bye bye.